Hey Ian, how are you doing? Okay, so we're about at time. We still do need a note taker. I put the link to the CodeMD in the chat. Do we have any volunteers to please help out with that? We have a lot of different talks today, and we want to make sure that we have a good representation for the minutes of what's going on. Hey, Frank. Oh, I don't hear anything.
Does it work now?
Yep, I can hear you now.
That sounds odd. That's better. That's also not better.
Do you want to volunteer to take notes for us?
Well, I'm not really up right now.
Yeah.
Not sure whether I'm operational.
Okay. Andrew McGregor has offered to take notes. That would be fantastic. And if anyone wants to help, please go to CodeMD as well. All right. So let's get started. Ian, do you want to try to talk again, just to make sure we can hear you? You click the send audio button. All right, sounds like we're not hearing from Ian right now, but oh, here we go.
Am I here?
Yes.
Okay.
Fantastic.
This is not as easy as it should be, but anyway, we're working through it. Okay.
Cool. Great. So we're going to start now. I'll be driving the slides. Ian, if you could keep an eye on the chat, and then also keep an eye on the time and remind us, that'd be great.
Sounds perfect. I have it open.
Lovely. All right. Welcome, everyone, to our first session of IETF 109 virtually. Hope the time zones aren't too hard on all of you. So this is IPPM, IP Performance Measurements. And this is the note well. If you haven't been to an IETF meeting before, please do take a look at this. This defines the contribution policies to the IETF, and you can find it if you just do a Google search for IETF note well. Here's some of the links that are relevant. If you're here, you're on MeetEcho. The Jabber room is very conveniently accessible in the chat panel, and our Etherpad for notes is in CodeMD. And we do have a note taker, and you can just watch chat and be our scribe. All right, so we have a pretty full agenda like normal. We're going to cover first some of our existing working group items. There aren't too many of these. A lot of them are pretty mature. Mainly, we have a bunch of IOM documents that are progressing. We also have a number of documents that we have open calls for adoption on, and so we want to go through those and discuss the status of those. After that, we have several other documents that have received a lot of discussion and would be candidates for calls for adoption soon, and then some lightning talks to round us out. to give an update on the status of documents. We've been a busy working group. We have a lot of products that we've come out with. So we have 4 documents in the RFC editor queue currently, and we have 3 others that are going through IESG and AD evaluation. So thanks to everyone who's been an author and a contributor and a reviewer for all of those, for all your hard work. All right, and then briefly, we did want to have a, the one document that we're not going to have a formal presentation on is the Ippm stamp Yang document, which if Greg is here, if you just briefly comment on kind of the status and where we see that going in the future months.
Okay, thank you. Just the last minute update. Stamp option TLV has cleared last discuss, and so we have enough support from ISG, and it's moving further. And the plan is that now start working actively on stamp Yang and bring it updated version to the next meeting.
That sounds great. Thank you. All right, and then before we get on to the rest of our agenda, it looks like Martin, our AD, is in the queue. Martin?
Let's see if this works. Great. Hi, yeah, I just wanted to kind of, one comment about the stuff in IESG evaluation. So as you know, Tommy, I just pushed the button on stamp option TLV, so that's off the RFC editor. So thank you, Greg, for staying on that. And IOM data has been, I've been waiting on a revision on that for about 3 months now. So I just want to make sure that Frank and company know that they, that the ball is in their court.
All right. Frank, I can't hear you quite yet if you're speaking, but I think you're also up for the documents. Cannot hear you right now. Cannot hear you. I'm not sure if I'm the only one. I don't seem to hear you right now. No. Anything? Should I try speaking?
Still not now.
Okay. Yeah, great. Just trying to turn it off and on again. See how this works.
Hello?
All right, great.
Hello, can you hear me?
Yes, we can.
Okay, excellent. Sorry for that. Yeah, and Martin, yeah, thanks for the heads up. We've been, I think, ping-ponging the ball between us, and but I think we have a plan forward, and Tal can speak to that in a minute, because I talked to Tal a couple of days ago, and he'll push out a revision, including the security remarks that you have, so that we can go and hopefully also progress the data draft. This one is around the 3 active working group drafts that we have, and we have split the presentation into 2. I'm just going to go briefly talk about the V6 options, which is a combination of the V6 deployment and the earlier V6 options, and then Tal is going to go and talk about the other 2. So on the V6 options draft, if you flip to the next slide, there is 2 updates that we've done. So you've seen 2 new revisions, the 03 and the 04 version. The 03 version was a reflection of the last working group meeting, where we at length debated well, how we should go and address the fact that, well, there was a section on deployment considerations which was outdated. That was this one paragraph that you probably remember that started with in order for IOM to work in IPv6 networks. Well, that was a stale paragraph because we had all the deployment considerations moved to the quote-unquote deployment draft. And so based on the chair's recommendations, we decided to go and merge the 2 documents as opposed to progress them independently. And so that happened, and the 03 version was just an editorial merge with kind of nuances to go and resolve circular references there, otherwise, right? Because the documents were referring to each other. So that's the O3 thing that happened, along with obviously removing the paragraph in question. And if you flip forward one additional slide, then you'll see that after the merger, Tommy, if you can go to the next slide. Okay, thank you. Then Tommy spent a little bit of time. That was one too far. Then, thanks to Tommy, he spent a fair amount of time on cleaning up the language, especially in the sections that came in from the deployment draft, so that we have a fairly solid document by now that includes extensive coverage of deployment considerations, along with the ask for code points for V6 hop-by-hop option types and the destination option type. And the only thing that we haven't really resolved was because, well, I think we hadn't really discussed that at length, and Tommy just came up with a suggestion. Was this like, the author list is too long, so the typical thing that we have. And so suggestion is to, again, move to an editor model, like we had it with the data draft, which would mean, like, given that Shweta authored pretty much the V6 option document and wrote it, and I wrote the deployment draft, to a large extent, the suggestion is just to go and have these two people as editors. And if there's nothing other major coming up, I think we can go and aim for maybe another revision, maybe none. And, well, we need one revision to go and clean up the author list, but maybe we can also go and do additional nuances if somebody has ones. But I believe what we're very close to being able also to do and go to working group last time. That's pretty much it. Any quick thoughts? Otherwise, we can progress to Tal and maybe just go and do the questions and answers at the very end of the presentation.
Yeah, I don't see anyone in the queue.
Nope.
Yeah, thank you for that update. And just a comment in general on our author lists. You know, this is kind of the same comment we're going to have on any document that has the warning within the within data tracker. So please, if you have a lot of authors, let's do an editor model. There's nothing wrong with doing that. So thank you for being willing to move to that authors. All right. Should we move ahead? All right. Paul, do you want to try speaking?
Yeah. Can you hear me? Can you see me?
Yes, both.
Great. Okay, so let's talk about the IOM flag draft. So next slide, please. Okay, so the status of this draft, basically we've updated the draft recently, and the most notable open issue was regarding the loopback flag. And just a reminder, the open issue was how to handle loopback on the reverse path. That is, when an IOM node decides to loop back a packet, what it needs to do when it sends that looped back packet, and what the other IOM nodes along the path need to do as they forward the packet back to its origin. So basically, we've updated the draft based on our thoughts from the design team meetings. And just a few words about the solution. The current proposal is basically on the forward path, the IOM packet has its loopback flag set. And then once an IOM node decides to loop back that packet, it clears that loopback flag. So on the reverse path, the loopback flag is not set. And now IOM transit nodes along the path just push IOM data. And once that packet reaches the IOM edge, the edge of the domain, basically the encapsulating node which originated the loopback packet, receives that looped back packet and detects the fact that this was a loopback packet based on comparing its node ID to the ID of the current IOM node. And this way, the originating IOM encapsulating node knows that it needs to terminate the packet. This is basically the solution, and it's already described in the current version of the draft. Next slide, please. So since we haven't had any comments about the solution, we're assuming that it's a reasonable solution. Of course, if there are any other comments, we'd be happy to hear them. But this was actually the last open issue we've had about this draft. And assuming we've resolved this, we would like to recommend to proceed to working group last call. Comments, please?
We have 2 people in the queue. Greg, do you want to go first? Let's see if I can unmute you. Okay, well, I'd like to unmute you, so hopefully Tommy can figure it out.
Thank you. Thank you for update, Tal. I still have a question of, so since IAM data is included in a loopback mode and sent back, how loopback then is different from the direct export option?
Yeah, we've had this question in the past, and again, it's somewhat of a semantical question, but direct exporting is, in my view, management plane entity. Basically, the result is reported to a collector, whereas loopback is used by the data plane, okay? Or it's a control plane entity, but it's used along the path of the data plane. So the result is reported back to the node which originated the packet. And again, in my view, loopback is intended to trace the path or to find the problem along the path, whereas direct exporting is intended to be reported to the management plane and to be used by the management plane.
But in direct export, as I understand, the destination of this exported packet could be their edge of IAM trace. So
right, it could, yes.
Effectively, it can be anything, including the node which is receiving in the loopback. So from that point of view, it does look like the loopback is a special case of the direct export.
Right, yes. Again, I think we've discussed this in the past. So you could implement loopback by direct export, but you would get a slightly different result because, again, in loopback, you get the IOM data from each of the IOM nodes along the path. And in direct exporting, you only get the information from a single IOM node at a time. So by receiving information from a single looped back destination, you already know all the nodes along the path.
Well, that kind of not as I understood direct export, because direct export works on each and every IAM node, capable node, along the path of the data packet.
Right, yes. Yes, what I mean is that in loopback by a single packet, you already get all the information about the nodes along the path.
No, I understand that each node along the path, if there is a loopback packet flag set, will send IAM data. So, which works like a link trace in Ethernet OEM. And direct export works the same, is just their destination of IAM data is configurable. So to me, the direct export does look like a more general and more flexible method of tracing and collecting their information from the trace of the packet. So IAM information from the packet. I think that we can take it to the list, but I still have this question and would like to clarify it before we move forward with the next step, progressing this document. Thank you.
Okay.
Thanks, Rick. Martin, do you want to go?
Yeah.
And we should definitely put this on the list. Sorry to not to confirm.
Yeah. So I did take a look at these drafts a couple days ago, and thank you for addressing the basic amplification issue, which I think we've discussed ad nauseum. I was attempting to think this through, and I'm not certain that for both this and direct export, I'm somewhat concerned about corner cases where multiple namespaces are interacting in ways that cause geometric or even infinite loops of IOM packets going back and forth. I will take that to the list because it would be impossible for me to explain verbally right now. But just please look out for that, and I'd be interested in your thoughts on this. If you would like me to talk through it, I can, but I have a feeling it just get too complicated.
Okay. Sounds like Mary's up. Yeah.
Yeah, I'm actually still worried about the amplification attack because it's different than with traceroute. With traceroute, you have to send one packet for every packet you receive back. And that's not the case here. Here you have to send one packet and get like bunch packets back depending on how long the path is. So I think this is not appropriately resolved, and also the discussion in the security section is like mentioning it, but doesn't provide any kind of measures to mitigate this problem. So I mean, like the minimum would be to talk about rate limiting, these kind of things you can reflect. But I think if you consider a different design for getting the same information, that will be worth it. Like instead of trying to reflect from every router one single packet, you could just send one packet back on the reverse part and accumulate information there, or something like that. Because that's a serious issue, and I think it needs to be further addressed.
So regarding amplification attacks, again, of course, Miria, we've received this feedback in the past, and what we've done in the draft is a few things. First of all, we point out the problem. We say we have a problem. We know we have a problem, so it's out there in the draft. Second, what we do is recommend to, or actually we don't recommend, the requirement is to use only a single data field in loopback packets in order to reduce the amplification problem. Okay, so the magnitude of the amplification is limited. And we also discussed rate limiting, like you mentioned. That's also one of the things that is described in the draft. So I think we at least tried to point out the problem and to suggest solutions. And I think your last suggestion to basically limit the number of responses you get from each message, that would just reduce the performance of the mechanism. So there's always a trade-off here between how bad the security attack is and what you can gain from the mechanism. So right now we've chosen the performance of what you can get from the mechanism.
Yeah, so the problem is there is a trade-off, right? And this is a serious attack. And the problem is this attack is not really limited in a protocol way that you can say, you know, it's never more than this much packet, right? It can be like a huge number of packets. and I think that's still not really satisfying. I did somehow overread the rate limiting because I was looking at the security section and it doesn't say anything there, so maybe you have to put some more text. But I think more consideration would still be needed.
Okay.
Thanks, Grant. I appreciate it. Let's maybe follow up on the list and see if we can come to a good conclusion on these issues. So
Sure.
back to you, Tommy. Thanks, Tom.
Okay, the next draft we want to talk about is the direct exporting draft. Next slide, please. So we had a long discussion about this, both in design team meetings and on the mailing list. And we've recently submitted an updated draft. We have two pending open issues, which we're going to discuss in the next few slides, so bear with me. The main change in the current version of the draft, which is version 02, compared to the previous version, is that we moved the discussion about the hop count to an appendix. So right now, in terms of the functionality of the draft, it does not define a hop count field, but it does have an appendix that discusses the need for a hop count, how it can be implemented by using the TTL data field, the node ID hop limit data field, and the trade-off between having a dedicated hop count field and using the existing data fields. Next slide, please. A few words about this open issue. So regarding the hop count field, we've discussed this a few times in the past, so just a few words to recap here. So it's either we don't use a dedicated hop count field or we do use it. So if we don't use a dedicated hop count field, the main advantage is that IOM nodes along the path do not need to update the direct exporting option header. They just need to forward it to process it, which simplifies what IOM nodes need to do in terms of direct exporting. On the other hand, using an explicit hop count field means that in some cases you get more information. So in specific cases, you can detect IOM capable nodes that have a problem in exporting, in performing the direct exporting functionality. Also, in some cases, the TTL is not available or not reliable. So you get an explicit hop count field which does this at the IOM layer. So we've had this discussion for a while now, and right now the way the draft handles it, again, is by having an appendix at the end. And hopefully we can resolve this issue and move on. We can discuss that at the end. Next slide, please. This is another open issue that we've had for quite a while now, and we've been struggling with how to resolve it. And the way currently the draft defines it is the direct exporting option has two possible modes, two modes of operation. One is to have an 8-byte option header, and the other is to have a 16-byte option header. And in the second mode, you also have two fields, which are sequence number and the flow ID. So these two fields are optional, and the way the draft defines it right now is that the length of the option header is implied by the lower layer headers. So you know the length by reading the header of the previous layer. So the open issue, and we've discussed this in the past, what happens if in the future we want to add more fields to the direct exporting option? That would mean we would have to somehow indicate which mode is used, which fields are used. That would be a problem. So how do we handle this open issue? One solution would be to use the reserved flags. Right now we have quite a few reserved flags. We can use some of them to indicate whether we have the optional fields or not. Another solution would be to just fix the direct exporting header to single length and have only the mandatory fields and not have the optional fields at all. That would mean that if you want the optional fields, you would have to add another IOM option, for example, the end-to-end IOM option, and have some additional fields there. So this is the open issue. We have two solutions. Right now, we are kind of struggling between these two solutions. Next slide, please. Okay, so that was actually the last slide. So any comments about these two open issues would be welcome, and we hope that we can resolve them soon. Tommy, can you hear me?
Hello? All right. Can you hear me?
Yeah,
Ah.
so if we have any comments, that would be great.
Got it. Yeah. Sorry, that looks like we were having some glitches on Meet Echo. Frank is in queue. Do you want to go?
Can you hear me?
Yes, now we can.
Okay, excellent. I wanted to go and just echo that the second option is, the second solution option is just one that came out of the IOM design team as a option that I believe is very clean. And I think that's already indicated on slide number 9. Hop count limit or hop count in DEX is something that is very similar to the hop limit that we already have for tracing. We have a sequence number defined for end-to-end in the current data draft, which we would redefine in DEX. And I don't really see a logic why we would need to go and make DEX a replication of what we have in other fields, as opposed to we use DEX as a very, very simple one, fixed header, no options, and then everything else that should go and have additional flexible fields could go into other options that are already built for tracing, for flexibility, right? So if we make a clear cut there, I think we resolve a lot of things by keeping DEX simple and by reusing what we already have instead of re-specifying. And so we could go and have another ref of the data graph at some point. And there is already a discussion and a couple of new drafts coming in. I think we have one in the lightning talks where people argue for new fields. And we can have a new field that says, well, flow ID, for instance, what we have in the DEX option right now, and add that maybe to E2E. So that would cut things and make it relatively simple. We can go and close stacks and then resolve the issues that we all have here. Thank you.
Thank you. Greg?
Good update, thank you. And definitely would like to contribute to the discussion. I will do some reading and send a note on the mailing list about the options. I'm a strong believer in TOV and think that that's the most flexible, and that's what we've done for stamp extensions. So maybe we can reuse this in DEX.
All right, thank you. And that'd be great to have a note to the list on that. Okay, and while you?
Hurry, we can't hear you now.
Yeah, you'll need to unmute you'll need to start sending audio yourself. If you'd like to speak.
You can try the reconnect audio button in the lower right. That worked for me when my audio died a moment ago.
All right, we're not hearing anything. Maybe you could put your comments in the chat, if that's okay. Because we should probably move on for time reasons. Yeah, so thank you to all for presenting this. I think we've gotten a lot of good input here. For the people who did comment, please send an email to the list about this. I think it'd be good to have more of this kind of discussion going on with the whole working group there. And as far as progressing things, I think it sounds like there needs to be work on both of these continuing. And I'd also like to see and ensure that we rationalize the relationship between the two different documents, DEX and the loopback flag. So I imagine them kind of progressing together rather than separately at this point. All right. Thank you very much.
Okay.
All right, so next I think we are getting into some of the documents that we have calls for adoption out, starting with the ones that are related to the spring working group documents where we have two proposed extensions to STAMP and TWAMP that have been spun off, so we could discuss those here in IPPM. So Rakesh, do you want to unmute? Great. And as a time check, we're running a little long on the last one, but that's okay because it's, still very important to our core work. So, yeah, we're going to reserve the same amount of time that we were planning for these documents. Thank you.
All right. You hear me?
Yes, we can hear you.
Okay, thank you. So my name is Rakesh Gandhi, and I'm presenting the two drafts that Tommy mentioned for TWAMP light extensions and STEM extensions for segment routing networks. These were part of the spring drafts, and they were spun off two IPPN drafts for the extensions for these protocols. Next slide, please. So we look at the requirements and scope, the history of the draft, the summary of the extensions proposed, and next steps. Next slide, please. So this is addressing two requirements. One is being the in-band delay and the synthetic loss, as well as standalone direct mode loss measurement. And the scope of this draft is TWAMP Lite. That's basically the messages that's defined in 5357, the messages with a user configure IP UDP paths, which are very similar to the one that's RFC 8762 stamp that became a standard recently. Next slide, please. So as we mentioned, there is a spring draft, corresponding draft for this IPPM extensions. And in the spring drafts defines procedures for end-to-end SR paths for SR MPLS, as well as SRv6 data planes, as well as for links. And here there is basically the protocol extensions that in TWAMP Lite there are two of them. And next slide, please. So there is a history of the draft. It's been around for close to 2 years now. There was one draft and then became two because of TWAMP and STEM. And now there are 4 drafts being split across 2 working groups. So this is why we are here. And next slide, please. So the first extension for TWAMP Lite is basically adding sender control code for the in-band response request. So it defines a flag. Next slide, please. And the second extension is basically a standalone direct mode loss measurement message. It's very, very similar to the delay measurement test message. Only difference here is that there are transmit and receive counters as opposed to the transmit and receive timestamps. There is a separate UDP port that we use for the direct mode loss measurement. So this way there is no intersection with existing delay measurement messages. These are new messages basically. Next slide, please. So as Tommy mentioned, these drafts are in working group adoption poll right now. So far we have received review comments on this one. The first one being on the status of the draft. Currently it defines extensions for TWAMP Lite messages. We think it updates to 5357 because of the message format change, adding a new field. It is informational right now, but because of the messages, probably it could be a proposed standard. We look forward to the input from the working group on the status of this. There was a review comment that maybe it's not specific to SR, it could be generalized or could be renamed. That sounds like a good idea for this draft. There were a few other editorial comments, abbreviations, or using correct terminology from the RFC 5357, which we agree. There is also showing us entire packet or loss. We should be very clear about this is direct mode loss measurement. Some editing to move some text from one section to another. So yeah, we would be making those editorial changes as well. There was a proposed, maybe we can use ICMP for direct loss measurement. We think that's out of scope for this. The focus of the draft is the TWAMP based messages. Next slide, please. Yeah, so these were the comments very specific to this draft. There are comments, some comments as well for the spring drafts, and there are some comments as well for the scan drafts that we will take a look the next. So many thanks for all your great support on the mailing list and the review comments that you have provided. This is in Ippm Working Group Adoption Poll, and or actually it ends on the 16th, so there is few more hours left for this one. And appreciate your review comments for those drafts today or anytime later as well. Next slide, please.
Yeah, and do we want to go? Do we want to talk about the other draft before we get to the queue, or do you want to take questions on this one independently?
The both drafts are very similar. Discussion could be very similar as well. Might as well go to the second draft and then
Sure,
we
yeah.
can.
Let's do that. Should we just kind of get to the differences, maybe?
Yeah, so it's very similar, except it's a RFC 8762, which is a standard now. And the one difference here is that STAMP allows TLVs. So we are taking advantage of TLVs as well for the extensions. Next slide, please. Next slide. We can skip that as well. So this is very similar to the TWAMP Lite message, so we can skip this one as well. Yeah, so this one, this is Delta for STAMP that we're taking advantage of TLV. So we're defining a few TLVs for the return path, and these are very specific right now for the SR, SRMPLS label stack or SRV6 label stacks, or the binding seed of the SR policy. Next slide, please. There's another TLV defined that identifies the destination node address. So when the query is sent for 127 address, this would carry the actual node address to verify that when the response comes, it's coming from the right node. Next slide, please. So, yeah, so this is also very similar to the TWAMP Lite. Only difference here is there is SSID, but otherwise it's very similar to, they both are similar, TWAMP Lite and STAMP. Next slide, please. Again, the review comments are very similar. So draft status, I think the previous comment doesn't apply. This one is already proposed standard, so we're just updating RFC 8762. Pretty much everything else is the same in terms of review. So yeah, this is also in adoption pool. Many thanks to your review comments and suggestions. Thanks.
All right. Shall we start with Greg?
Go for it, Greg.
To the slide 3 of the first presentation.
This one?
No, the first presentation on TWAMP.
Yeah, this is the first presentation.
Yeah, thank you. Slide 3.
This slide.
One back. No, this is 3. At least it's number 3.
Yes.
So, TWAMP Lite already provides delay and synthetic loss measurement. So I don't really see why it's a requirement that you're mentioning. The second, my question is, so you say that there is a requirement to support direct mode loss measurement. I agree that direct mode loss measurement is useful, but I think it will be helpful if the working group discusses how to do it, because what appears that you propose 2 different solutions for one problem. So you propose some extension to TWAMP Lite, which is a non-standard and it's only informational. And you propose something to STAMP when all that can be addressed with one mechanism, as I pointed out in my comments, using multi-part message extension to ICMP. And another thing that I wanted to note is that you haven't responded to most of my comments that I sent in attachments on my IPPM list, so I'm looking forward to hear from you. And just to save time, that will be it. So I would like to move this discussion of my comments to the mailing list.
Do I respond now, or you want me to respond on the mailing list?
I think that just for the sake of saving time for everybody, we can continue discussion on the mailing list.
Yep.
The only thing is that just to say that I have responded to the emails as an attachment. I think the questions were in the Word document while the responses are in the attached email format, but I have replied to all your emails.
You reply to emails, but not to comments.
No, it's the same. Whatever comments you had in the Word documents were in the emails. I went through it and I replied them as email attachments to the, if I can convert them into Word document and send it if it helps, but I have replied to your comments.
Okay, please send them so that IPPM working group, because again, because this two documents, actually like two pairs of documents being discussed on both Spring and IPPM lists. I'm not sure that everybody in IPPM list group reading Spring working group discussion.
No, I have replied to this IPPM working group email as attachment, email attachments with all the comments or answers for your comments. So please do look at it. It should be in the archive. I will read.
Okay, I'll look in archive, but I haven't seen it.
Sounds
I
good.
can resend it, no problem.
We can resolve on the list. And we also have Martin in the queue. Martin, do you want to speak up?
Thank you, Rakesh, for the presentation. I read this for the first time a few days ago, and I was really trying to understand the motivation for this work. And honestly, I had a lot of trouble getting that out of the introduction. And some of that is what Greg was saying about, you know, what TWAMP already does and so on. But like, so if I understand correctly, direct mode loss measurement means that there is something counting losses in the network. You're just trying to query it rather than measure it directly with the TWAMP packet. Is that correct?
Yeah, so TWAMP allows the synthetic loss, but what we're collecting the counters is the actual customer data traffic.
Okay, that's interesting. It's very much conceptually different from what I perceive a lot of IPPM stuff to be, which is like measurement techniques. To like say that, you know, to say that there's already a device doing this measurement, we're just trying to like extract it from the device is like, why not just use HTTP or something to get that?
Yeah, so we already have the TWAMP like machinery which collects timestamps today, and enhancing the whole thing just to collect the counters from TX and RX side. This has been done in like Y1732 or RFC 6374. So there are precedents of this hardware capabilities that exist for the counters, the hardware capabilities that exist for TWAMP. So there is a lot of motivation to add these small extensions and for segment routing use cases where we are measuring the actual customer traffic loss. This is a very good application for it.
Okay, fair enough. I hope that between my comments and Greg's, maybe you have some ideas on how you could flesh out at least like the introduction of this document a little more, just to sort of say like what problem exactly is being solved, and maybe not get too deep into like Spring terminology for people who aren't familiar with it. Thank you.
Yeah, for sure.
All right, so it looks like we've drained the queue. You know, on the call for adoption, we've had a lot of good support from a number of people, but I think that's also due to it being cross-listed in the work with Spring. The comments that Greg and Martin bring up are very good. What I would like to hear more of is comments and reviews and thoughts on these particular issues from, you know, some of the IPPM working group members who did a lot of work on TWAMP and STAMP and the design and the kind of original discussions around those, and to comment on kind of the appropriateness of this, or really what is the right way to solve these problems. So I can repeat that on the list as well, but you know, this is a call to get kind of more input and higher level review like that. And Greg, did you want to say something?
As I noted in my review comments, this proposal and a similar proposal on STEM does look like it defines a new protocol, and that's actually reflected in the slides, that this is a standalone functionality. So it's not an integral part of TWAMP test or STAMP, because it defines a different format for the base message. So it's not an extension of at least STAMP and TWAMP, but it's a new protocol. And it should be viewed as a new protocol that does only one thing, collects counters. That's all.
Thank you. All right. So I think it's time to move on for this one. Thanks again, everyone, for your comments, and we'll try to follow up with a good summary on the list. I think next we have Rudiger.
Ippm connectivity monitoring, third version. I applied for adoption at the work group, and this is actually running. The scope is monitoring segment routed subpath or links and to detect and locate loss of connectivity and congestion, and that's the value add. Detecting the location of congestion, which is enabled if this draft is supported. It's based and only working with MPLS segment routing. I'm not sure whether it could work with IPv6 segment routing too. So properties is monitor network sections with known topology, not unknown ones. One measurement path per monitored link. That is important. The design is so that you roughly have the same functionality as if you work with ping. And yep, there is one important issue. Change point detection doesn't require well synchronized timestamps, so it's a differentiating metric. And it applies segment routing to allow for an a priori design network tomography evaluation and a limited number of monitoring systems. So it's important. You do not have to work on routers. You can work on routers. So it's just depending on what you want to use it for. And it does estimate round trip delays and one-way delays of monitored links or path as it is designed right here. And yeah, the aim is to standardize suitable metrics. And as I mentioned, it's a tomography approach. Next slide, please. So this is shown here in the slide. I do not want to go to details, but you need to be relatively strict in setting up paths like shown here. And I think that should be done in an automated fashion if you run it out on larger scale. But this is not part of the draft. The draft is only dealing with the methodology and the metric. Right. The important thing is every measurement path is set up as shown above. You have one U loop, you have one downlink measurement, one uplink. And below you see that on each measured path, you have pretty much the same mix of 3 different paths. The green one is the uplink one, the blue one is the U loop, and the red one is the downlink one. And if you do that, you can evaluate the signals and have a non-ambiguous indication of whether there's connectivity and whether there is congestion. And if there is congestion, you also are able to identify the interface where there is congestion. So this is a difference to ping, where you do not know exactly where the congestion is located because you cannot differentiate that. So that's the value add of this contribution. All right, I don't want to go to details. If you have time, read the slide. It roughly tells you what to do. I received questions during the discussion on the list, and these were related to the temporal resolution of event detection. So there is a little text in the draft. The text on this slide is likely a bit larger, and the illustration is better. If you space all the measurement packets by some TPD, then I think it's a conservative and fair guess that you will be able to detect events of a duration of more than 2 times TPD or longer. Now, as you see in the figure, that all the packets of all flows are having the same periodical distance measurement interval, and so that I think is quite straightforward. I just made up my mind and think if you are working on a time scale which is much smaller than the paths you detect, then you might be able to work with temporal properties. I just see that I was hard to hear, and but I didn't think that through. So this is a quite simple answer, and it tells you what can be done. The aim is not to replace any hello messages which are exchanged directly on a link with neighbors. The aim is to monitor networks on a time scale of maybe seconds, maybe minutes, and just be aware where your forwarding doesn't work, because that is what this draft does. There is no interaction with routers. It's only measuring on forwarding paths. All right, and that was the presentation. If you're interested, read the draft and support adoption. I don't know whether this should be discussed here. I don't know how big the segment routing, MPLS segment routing know-how of this workgroup is here, so I didn't try to present it in segment routing yet. If there is a sentiment that I should do so, please let me know. Thanks. Are there any questions?
Greg's in the queue. Greg, do you want to go?
It's a very good, interesting work, and a lot of interest I have to it. I just wanted to note that if you see the scale of detection in terms of seconds or even 100 milliseconds, that might be too long period, because if we'll take local protection, like TILFA, that will work on 10 milliseconds interval. So there are local protection, there are defect that is locally detected between two nodes would not be noticed. So I think that that's something important to really take into account, that we might have a local switchover and reroute of the path, and the system would not notice.
I'm not sure if it changes the forwarding pattern and you measure different times, then you will notice it. If you are looking at the situation of a bundle, then it might go unnoticed. I agree. But then that depends on what you want to measure. I had a conversation with someone else who tried to suggested to monitor end-to-end paths, and then that's something completely different. So there are multiple opportunities where you could use that, and it just depends on what you want to do with it. But as I mentioned, I do not suggest to use it as a replacement of hello messages, because that is too much of a research issue to me.
Mm-hmm.
Thanks.
Okay, let's continue on the list. Thank you. I appreciate it. Thank you.
Great. Thanks. Jay, you're next up. We can't hear you.
You'll need to unmute yourself. Yeah.
You might need to reconnect audio. It's in the lower right.
All right. Yeah, so we're not hearing from you, Jose Ignacio. If you want to unmute, please do. Otherwise, I think we don't have any other people in queue. Yeah, so we haven't gotten a lot of feedback on the list on this one. Thank you, Al, for sending your comments. And Greg, if you'd like to kind of reply on the list, that would be great as well. I would ask that we get a few more people reviewing this document and commenting whether or not they think it should be adopted before we move on. But otherwise, I think that's good. Thank you so much, Rüdiger.
Thanks.
All right. Next, we have the IOM conf state document.
Hey, Joe, we can't hear you. Oh, we can now.
Okay. Hello,
Perfect.
it's Xiaomi speaking. This presentation is on echo request reply for enabled in situ OEM capabilities. I presented the earlier versions of this draft at the previous IETF meetings. And this time I present the 07 version of this draft. Next slide, please. Firstly, I want to recap the intention of this draft. This draft provides a method for the IOM encapsulating node to discover the enabled IOM capabilities of the downstream nodes. The method is more useful when there is no centralized controller within the IOM domain. In this scenario, the IOM encapsulating node cannot construct the IOM header via configuration or by querying the centralized controller. In other words, the method is a complementary IOM tool. It may not cover all IOM deployment scenarios, but it makes IOM deployment more flexible. Next slide, please. Next slide. Okay. Since 01 version of this draft, we've had a good discussion within the working group, and many good comments have been received. Here I list some major updates from them. We adjusted the title and the scope of this draft to make the intention more apparent and more accurate. Firstly, among the title, IOM configuration data is changed to enabled IOM capabilities, since the former is too associated with netconf and YARN. Secondly, 3 use cases identified. They are IPv6, MPLS, and SFC. And this method is partitionally restricted to explicit paths, whether strict or loose. Thirdly, in the current draft, we don't provide specific IANA requests for ICMPv6, ASP ping, or SFC ping. We ask for guidance from the working group chairs on whether to include them in this draft or in separate drafts. Next slide, please. Since 01 version of this draft, the defined TOV, sub-TOVs are reclassified, and we adjust the relevant TOV, sub-TOV definition. Echo request and echo reply TOVs are divided into 2 separate sections. list of sub-TOVs is removed from the echo request TOV. Tracing capabilities sub-TOV is divided into pre-allocated tracing capabilities sub-TOV and incremental tracing capabilities sub-TOV. At the same time, F bit is removed. And the egress MTU field is extended from 14 bits to 16 bits. Next slide, please. Some technical changes have been made to follow the updated IOM data draft, and the operational guide section has been enhanced. Firstly, list of namespace IDs field is added into echo request TOV, and the respective namespace ID is added into respective echo reply sub-TOV. Secondly, IOM trace type field is extended from 16 bits to 24 bits. Thirdly, in the operational guide section, we add one alternative for the IOM encapsulating node to send an echo request to each IOM transit or decapsulating node directly without the TTL expiration. Next slide, please. Following the newly adopted IOM direct export draft, an IOM DEX capabilities sub-TOV is added. This sub-TOV includes IOM trace type field and namespace ID field. Except for the updates I just presented, we've also received good comments from Dhruv Dodi before this meeting. And the updates on addressing these good comments will be included in the next revision of this draft. Next slide, please. Next steps. This draft is in call for adoption. Currently, we are looking forward to the conclusion. That's all. Thank you.
All right, thank you very much. Do we have any comments or questions?
Martin Dukes in the queue. Go for it. We cannot hear you. Sorry, Martin.
You have
Let's take
video, and I'm not going to let you
There we
share
go.
your screen.
Okay, sorry. Yeah, there's a little latency in this. Thank you, Xiao, for the presentation. So am I understand that then every one of these echo requests generates an echo replies for everyone to advertise their capabilities?
Sorry, it's not very clear to me.
So if I understand correctly, every echo request generates multiple echo replies from each hop in the network?
Yes, we can use TTL for the echo requests. So echo requests, there are multiple echo requests, and every echo request generates one echo reply.
Okay. So there's not an amplification problem. Wonderful. Have you considered possibly is the desire here to figure out what is like the actual common set of capabilities that the entire path is able to support? And if so, could you not like have essentially like a list of capabilities that travels through the path and filters out the capabilities that are not common? It's like, for instance, hop 1 would say, oh, I can do 10 different things, and hop 2 says, I do 8 of those. And so then eliminates 2 of the fields and so on until you end up with, the 5 common things that the entire path uses. So you could do it all in one message instead of a bunch. Or is that not what you're trying to achieve?
Sorry, it's not
Yeah.
very clear because there's noisy.
Okay.
I can answer Martin's question.
Okay, correct. Can you help?
Yes. Sorry to jump. Well, that is one of the scenarios that Martin described. So finding their lowest common denominator. But at the same time, the goal is just to learn the capabilities of each node, and that can be used in some other scenarios.
Okay. Thank you.
Frank?
Yeah, I have, I think, a question that I asked before. So what we're basically doing here is we're adding management capability into ICMP and other echo request protocols. And I think the question is why? Because we could go and do the very same with netconf yang if you're just querying every single node, right? So why would we need that in ICMP? And if we do convert, or if we believe we want to go and convert ICMP into management and capability discovery protocol, is IPPM the right place to go and do that? Because, well, yes, initially it is done for IOEM, but I think there is a broader question here that we should go and get resolved before we adopt it here.
Thank you. Firstly, I don't think it's a management protocol because I have already explained the intention in page 2 of these slides. The intention is for the IOM encapsulation node to discover the capabilities and use this discovered capabilities to construct the IOM header. So I think it's more like a tool, a complementary IOM tool. So I don't think it's management specific. Secondly, for the IPPM working group, whether or not IPPM is the appropriate working group for this work, I think I have already sent this question before, and I think the comments to my question is that this is IOM specific, so I need to present this draft and get adopted in IPPM before I can do any next actions, next steps to. Actually, I have already said in my presentation that I asked for guidance from the working group chairs on whether to request INR request in this draft or in separate drafts in other working groups. So that's the intention.
Thank you.
More people in queue. We should probably cut the queues after this. Mark?
So I have comments about the draft. Since the draft is trying to extension to the ICMP and the MPSP protocol, so I'm not sure this is the right working group to progress this work.
Yes, I've already explained to Frank. So I think it's. I ask for guidance from working group chairs on this.
Okay. Okay, thank you.
Gently. If you're speaking, we cannot hear. Oh.
Hi, guys. Okay.
Hello.
Hi.
Can hear you now.
One comment. Like, can can this mechanism to be used in like multi-domains of instance AI, something like this? Because like by using the ICMP, I think we can like get information of the nodes from other domains, but I think it will introduce some security considerations issues. Like, what do you think about this?
For the specific security issues, we can discuss it further on the mailing list. So if you can find some security issues, I think welcome to comment on the mailing list.
Okay, thanks.
Thank you.
All right. Thank you. And just to kind of reiterate that point, any of these comments, particularly the ones that were raising some concerns, please do reply to the offer adoption field on that. I don't think I've seen a lot of those on that particular thread. So please do chime in. All right. Thank you so much. I think it's time to move on.
Okay, thank you, Tommy.
Thank you. All right. And lastly, of our documents that we're considering for adoption, we have the IOM Yang document.
Hello.
Hello.
Okay. Yeah.
Your audio is extremely quiet.
Oh, can you hear me?
Yes, but please speak up.
Oh, can you hear me now? More clear?
Yeah.
Not very
we can
well.
hear you.
Okay.
Let
Sorry.
me
I
try to
can't
be
hear you very
louder.
well.
Okay. Let's go.
Yeah, let's go ahead.
Yeah.
Everyone just turn
I'm
up the
Tian
volume and I'll mute.
Yeah, I'm Tian from Huawei, and this is about the Yang data model for IOM. This next slide. Next, please. Oh yeah, and this draft was initially posted on March 2018 and presented on IETF 1.1, 1.2, and 1.8. We got comments from Greg, Richard, Tom, and Drew. Thanks all for your comments. We have evolved several versions to align with the latest IOM data draft and the IOM directly export draft. And the latest version corrected the admin type things as suggested by Tom, including the reference copyright tree diagram and the correct reference of the proof of transit and so on. And after we submitted these slides, we received 2 more detailed comments from Drew and Richard. Not updated this slides, but I will discuss this later. Next slide. The model structure is like this. The model is organized as a list of profiles. As suggested by the working group, each profile container is enabled by the corresponding features. So the device do not need to support all the features. Each profile associates with one flow and the corresponding IOM information. The flow is typically identified by ACL and can be defined flexibly. We support 5 profiles here: the incremental tracing, the pre-allocated tracing, the direct export, proof of transit, and the end-to-end. Multiple IOM data types can be encapsulated into the same IOM header. The latest comments I read from Drew is to make this model more flexible and reusable. In other words, one profile could apply to different protocol layers and apply to different flows. if we want to do this, one profile could apply to different. We may need to decouple the flow and the protocol. The protocol decouple the flow, the protocol, and the I1 profile, and so that we can flexibly compose them. Here, I want to know your opinion in this working group. Do we have this requirement? And of course, we can continue and discuss this in the mailing list. And another question is, do we allow all options for one flow at the same time? I think the answer is partially yes. For tracing and end-to-end option, yes. And for incremental tracing and allocated tracing, I do not think there's any case on this. So maybe we may need some more strict rule here. And next. The pre-allocated tracing option will create pre-allocated space for each node to populate its information. The structure is as follows, and the next. And this is the incremental tracing profile, and next. And the direct export option is used as a trigger for I1 node to export data to a receiving entity. And next. And the I1 proof of transit data is to support the path or service function chain verification use cases. It's imported from the draft in SFC working group. Richard made this latest comments. Made the latest comments on this. So one discussion is whether we should incorporate the ports directly in this I1 model, or still like this, we import it from the SFC. Any comments here? And
Not
next.
seeing anyone move to. Yeah, thank you.
Okay, the next. And the IOM edge-to-edge option is to carry data that is added by the IOM encapsulating node and interpreted by the IOM decapsulating node. And next. That's all. And any more comments? Thanks for all the comments that's received in the mailing list.
Yeah, thank you. It looks at this point that there isn't anyone in the queue. Someone speaks up now. And we did get a lot of good feedback on the list, so thank you for everyone who did respond there. All right. So yeah, thank you for your presentation. And we'll get back on the list about the status for adoption.
Okay.
Thank you so much.
Thank you. Thank you all.
All right. So now we're going to go on to the documents that are not in current call for adoption. And actually, I was expecting that we would have the hybrid two-step next?
I may have thrown the slides slightly out of order.
Yeah.
Apologies.
Or actually, I don't know if it matters too much if Maro's already ready. Oh, okay. Let's keep to the agenda as it was and take 10 minutes to talk about the hybrid two-step, if that's okay.
Ready. Okay, next slide, please. Okay, so we had a good discussion on the mailing list and added how hybrid two-step can use IAM or and alternate marking domains, and clarified their scenario of the late follow-up packet, so when their HTTP timer expires. And we welcome Haoyu as a co-author. Next slide, please. So the telemetry can be viewed as a union of three tasks: generating telemetry information, collecting, transporting telemetry information, and then correlating telemetry information. We are working on a number of solutions to their telemetry, and that includes IEM trace options, and when their information is collected and transported in a data packet itself, and the trace option can have two sub variances, pre-allocated and incremental. Then we have a direct export, which combines the proposal that postcard-based telemetry I. There is a postcard-based telemetry M, which uses as a trigger methods of packet marking, for example, as described in RC 8321. So in direct export or marking, so the difference only in what triggers the information generation. Their method of each node collects the information and then transport it to their collector using a out-of-band packet. So out-of-band in terms of relative to the data flow which generated this telemetry information. Next slide. So each of these methods that we're pretty much well familiar with has some advantages, but at the same time challenges. So the hybrid two-step is a method that is complementary to all the methods that I mentioned, and it uses their specially constructed message, a follow-up message, to collect telemetry and transport it along the same path as was followed by their packet that triggered their telemetry information. So since the trigger packet is network layer specific, the follow-up packet uses the same encapsulation, so to ensure that it follows the same path. But the method can be flexible so that hybrid follow-up packet is out of band, even though it follows the same topological path, but because it would not necessarily share the same QoS, so it would not really take the resources, especially which is for services that are sensitive to latency, jitter, and packet loss. So in a way, it uses their management plane. Another quality of a hybrid two-step proposal is that there is no limitation of of amount of information collected along the path, because any transit node would be capable or required to be capable to generate additional follow-up packet using the same encapsulation as their original data packet. Next slide, please. So this outlines their proposed format of follow-up packet, the transport network encapsulation, which should be identical to the one that used for layer-specific trigger packet, and then information that is required for identification of the flow. The sequence number, it's a sequence number in a queue of follow-up packets that are triggered by the same data packet, and then telemetry information organized as TOVs. Next slide. So here it's an illustration how their method of collecting, transporting their telemetry information works. We have a flow of data packets, then there is a trigger packet which produces the follow-up packet. And follow-up packet, the original follow-up packet may be filled with their telemetry information. Then their transit node, in this diagram, it's a node C, can generate another additional follow-up packet, and then they will arrive at the egress node, which will remove them from the network because it's a destination of the data packet, and then the information can be analyzed or sent for the processing. The advantage of it is that it's easy to correlate because all the information like IOM trace options collected together. Next slide. So the previous diagram shows how hybrid two-step method works in a point-to-point case. It works in multicast distribution tree as well. And that's works efficiently because there is no replication of telemetry information. So I would not go through this. You can read the draft or bring the question on a list. But the diagram shows that only their information of the multicast sub-tree is collected in a follow-up packet. So the information that was collected upstream is not replicated on all their branches. Next slide. So IOM can be used with the hybrid two-step method of collecting information, and we added a description of how what information from their IAM header can be used to trigger, and how this information can be encapsulated into their payload of follow-up packet. So that's an intention of using their information defined in IAM data, but encapsulating in TOVs for flexibility. Next slide, please. So we are looking forward for comments, discussion on the list, and very encouraged by their thought of adopting this work at some point. Thank you.
Thank you, Greg. Do we have any questions, comments?
Great. Mary.
Hi. I'm wondering if that's actually this work is actually in scope for IPPM, because it somehow rather defines an entirely new protocol than like a metric or model or whatever. So that should definitely be discussed before starting working group adoption, I think.
Okay, thank you. Again, it's what's being proposed here is not that different from the direct export method, because direct export generates packet with the telemetry information from each transit node, and hybrid two-step takes it a little bit differently and combines the methods in IEM trace option and direct export. So, but that's something for working group chairs and AD to decide. But we'll appreciate their consideration and advice where this work can be anchored.
Yeah, and thanks for bringing that up. I think also there's a general question that this raises to me of making sure that as we are doing the work such as direct export, that we have a kind of good and consistent story, and we're not doing too much overlapping or conflicting work, and to see how much can we unify these approaches. All right. Okay, it doesn't look like we have anyone else in the queue, so thank you, Greg. Now,
let's move back to move forward.
Ooh. You got it. Okay. Or do you want to come back on? Thank you.
I guess that you can hear me.
Yes.
It's a little quiet, so just speak up. Other than that, we're good.
Okay. Next slide.
Next slide, Tom.
Okay. This draft is about explicit flow measurements. Explicit flow measurements employ a few marking bits inside the header of each packet for loss and delay measurement. It's a protocol-independent technique and especially valuable for encrypted header protocols. Example given quick. The metrics described in this draft are about precise RTT, spin bit plus delay bit, round-trip packet loss, spin bit plus round-trip loss bit, and there are two options about one-way packet loss: square bit plus loss event bit, and square bit plus reflection square bit. Next slide. Okay, there are some implementation that are already made and demonstrated in the hackathon, for example, during the quick measurement project. And the implementation are actually free. Telecom Italia implementation is on Android mobile phones. The probe is inside the mobile phones, so the idea is to put the probe not in the network but also in the devices, user and user devices. The Ericsson implementation on core network probes, and the Orange Akamai implementation, the first one, already in field by 2 years, the Akamai production CDNs and core network probes. Next slide. I recap shortly the round-trip time spin bit that is used to mark the packet in a client-server protocol to measure the round-trip time. So the idea is to create a square wave signal that bunches between client and server, and the length of the signal is equal to RTT time, round-trip time. Next slide. So an observer can measure the length of the square wave signal, and this length is equal to RTT. And there are some little issues, little or big, depends from the view. The first one is about the packet loss, because the packet loss of packets cause wrong estimates of RTT. Another issue is the ordering that can change the spin, the period edges, and to create new periods, new short periods. And so we can have wrong measurements. The last one is the so-called application delay, because if there are holes in the traffic, the period can be reflected in time, so we can add delay to the RTT. Next slide. The first new idea of this draft is to add a bit, a marking bit, a so-called delay bit, that marks a specific packet inside the spin bit period. So the spin bit period is composed by many packets. One packet, usually the first one, is double marked. So an observer put on the path can measure the distance between two delay sample, two double marked packets, and so the measurement is more precise because there isn't the ambiguity caused from packet loss, because if the packet is not detected inside a spin bit period, the measurement is not done, and the delay bit detects a specific packet, so there isn't the possibility that you can measure different packets on the edges of the periods. Next slide. Another idea is about the packet loss, the second important measurement that we can do using these marking bits. We use one bit to mark some packets inside the flow. This packet bunches between client and server two times. So there are two periods, two train of packets that bunches two times, and the observer can measure the difference between the number of packets of the first train and the number of packets of the second train. So in this case, it's possible to have a statistical measurement of losses only seeing these T-bit marked packets. This works only in conjunction jointly with the spin bit, because the spin bit gives the period time inside the T-bit are considered. Okay, next slide. Okay, this is about the one is different before the previous one, because this is one direction, one-way packet loss, the traditional packet loss, because the round-trip packet loss is a new kind of measurement in which we can detect where the packet loss occurred, but in this case, measuring the one-way packet loss, we can measure the direction where the packet loss occurs. The first bit used for this kind of measurement is the square bit, that is first described in a draft of a couple of years ago, the draft Ferrier-Chew quick loss bits, and is based on the alternate marking classical techniques already defined in RFC 8321. The idea is to mark blocks of packets, 64 packets, for example. So if the blocks are of different length, shorter length, there is a packet loss. In this case, the measurements happens between the endpoint and the measurement point. It's quite different because the previous techniques about round trip loss or round trip time. In this case, the measurement is not an end-to-end measurement, but is between the client and the observer in one direction or the server and the observer in the other direction. So we can measure the loss between the endpoint and the observer. Next slide. If we have two measurement points, we can do some interdomain packet loss, because we can do the difference between the packet arrived in a server and the packet arriving in the second observer. So we can measure the difference, the packet loss in between the two observers. This is very useful to locate the losses inside the network, inside the domain network of a telecom operator. Next slide. Okay, this kind of measurement, the qubit measurement that is between the endpoint and the observer, can be complemented by an end-to-end measurement that in this case is made by the L bit, the loss event bit. The loss event bit idea is to mark a packet with this L bit, put 1 when a loss is detected by the protocol. So the idea is to have a connection between the protocol measurement inside the application and the network measurement, marking a bit in a packet, every packet loss event detected inside the protocol. So is only one end-to-end measurement. An observer measure in every point is put, it always observe the end-to-end measurement on this direction, on this path. So complementing, next slide, complement is this kind of measurement with the previous one, the qubit. We can split the packet loss between the observer and the server, and between the client and the observer. So we have all the possibility to split the measurement and to locate the losses. Next slide. The alternative to L bit is to use the qubit coupled with the R bit. The R bit is a measurement that simply reflect the losses from one side to the other side. So the qubit mark the packets, the 64 packets, for example. If you find less than 64 packet marked from the other side of the network to the other endpoint, this endpoint reflects a period that starts with this number 63, for example, 62, if there are this 1 or 2 losses in one side. So we can measure on the other side the losses on the first way and part of the losses of the second way. So we have, in the next slide, please, the possibility to complement these two measurements, to have to split the losses between the two directions. On one direction, for example, we can subtract the qubit measurement, the losses in this direction, to the 3/4 measurement seeing the reflection bit. So we can measure in one direction the end-to-end losses in the opposite direction. This is using only one direction server. In the next slide, if we add two direction server, we can split the measurement into parts, a round trip losses right, a round trip losses left, or the single losses between the observer and the client, and between the client, the server and observer. Okay, next slide. Okay, this is a very complicated slide. I let only for documentation. We can study directly on the draft that compare all the possibility to measure the losses using 1 or 2 bit pros and cons. Next slide. Using 3 bit, we have 3 possibilities to measure the precise RTT using 2 bit and round-trip packet loss using 1 bit, or using only 1 bit for spin bit for delay and 2 bits for the packet loss one way, using the 2 alternative possibility, qubit and L bit or qubit and R bit. Okay. Next slide. So these metrics are deeply discussed on the working group inside the mailing list. We demos this technique inside the hackathon, and we joined the 2 previous drafts that are about the packet loss, and we joined in one draft, this one, comparing loss bit and reflection bit. That are the 2 alternatives using jointly with the qubit. We request the working group adoption and welcome for question and comments. Okay. If there are some questions, in the next slide I put only some reminder to the other draft that we presented, the device measurement draft, that the idea is only to put this measurement on the device user. It presents some advantages. You can read on the system.
All right. Yeah. Thank you. And I don't think we have time to go over those slides now, but those are available. Does anyone have comments on this?
Thank you for merging these 2 drafts, by the way, and I think this is pretty interesting work overall. So I would definitely appreciate more feedback on the list.
All right, looks like we have a empty queue. So yeah, again, thank you for doing this. Thank you for doing the work to merge the documents and proposals. And I think this is one that we would like to consider for adoption. Great. And so for people watching the clock, we are pretty much at the end of our time, and we've gone through all of the documents that we wanted to kind of have full slots available to. Unfortunately, it looks like we don't have time for any of our lightning talks. But I would like to remind people that those slides are available, and to please take a look at those slides. And if you have any questions about those documents, shoot them to the list. And what we'd like to hear is kind of more good feedback on those kind of before we progress or have larger slots for those documents. Any other questions from anyone else? Any other things we should cover?
Okay. Thank you, everyone.
And thank you to Andrew for doing the notes. Looks like those are nicely filled out, and we very much appreciate that and your help.
I agree.
All right.
Have a good morning, evening, good night.
Thanks. Have a good IETF, everyone.